Hey everybody, I'm Mark Payne. Welcome to part 5 of this series on NiFi anti-patterns. It's been a while since I've made any of these videos, but I'm back now. You know how it works at this point, so let's just dive right in. So the first anti-pattern that we're going to take a look at today is the overuse of the primary node. So it's very typical to have a data flow set up where you only want the source processor running on a single node in your cluster. A great use case for this is when you want to perform a listing of all of the files on some remote server, like a list SFTP or a list FTP processor. And then you might want to distribute that listing across all of the nodes in your cluster, but the listing you only want done on a single node. So this first processor here, we would go to the scheduling tab and we'd set the execution to primary node. But what we often see is that users will come through here and they'll then go ahead and set each of the different processors in their flow to primary node. And it's common for people who are just starting to use NiFi to see this primary node on the source processor and think, well, that means that every processor in my flow then needs to be primary node because only the primary node is going to have any data to process. But the problem with this is that the primary node can shift from one node to another. And what happens is that this first processor will run and queue up some data, and then another node in the cluster ends up becoming the primary node. And as a result, we have data queued up here that hasn't been processed by the fetch SFTP processor yet. And as a result, the data just sits there because the data belongs on a node that's no longer a primary. And so really what we want to do is we want to make sure that only the first processor in our flow is scheduled to be primary node. And if you notice, we now have fetch SFTP actually is invalid. And if you hover over that icon, you're going to see it's because the execution node is set to primary node only. And the reason that this is invalid is that we've seen this anti-pattern used so many times where people go through and start setting different processors to primary node only that we realize there's never actually a case that it makes sense to do that except for source processors. So in the latest version of NiFi that hasn't actually been released yet, you'll actually see that these processors become invalid if you try to configure it to run on primary node only and it has any incoming connections. There's never actually a good use case for that. But we see people doing this because either they think that if the source is primary node only, then each of the processors in the flow needs to be primary node only. Or some people will think that if they schedule this processor to run on primary node only, then that means that all of the data will funnel automatically to that primary node only, and it'll be the only one who actually does the processing. But that's not the case. The data will remain in that queue in whichever node that it arrived in. It's not going to automatically distribute. And so we've also seen people will have this idea then that what they should do is come in here and configure this node, or I'm sorry, this connection to have a load balance strategy of single node. And then it makes sense to configure this processor for primary node only. But that's a mistake as well, because whenever we say that we want to load balance to a single node, that single node is not necessarily the primary node. And the reason for that is that, as I said, the primary node can switch from node 1 to node 2 to node 3, especially during a restart or even while the processing is happening. And if we have 50 gigs or 100 gigs of data queued up in this connection, we definitely don't want to say, well, now I'm not the primary node. I want to send it to the new primary node and automatically just start pushing all of that data over the network to another node. We really want to make sure that whichever node we choose for the data to go to, the data is going to keep going to that one node only. So it's not going to actually be the primary node necessarily. It may or it may not be. But we don't want to end up in a situation where the data is sitting in these queues not getting processed. So we want to make sure that the only time we set a processor to run as primary node only is if that processor is actually the first processor in the flow. All right, so the next pattern that we're going to look at today is overuse of the convert record processor. Now, it turns out this processor has become quite popular. However, the reality is that it's pretty rare that it should actually be used. And so the idea behind introducing convert record was for a flow that looks like this, where you've got some data coming in from some location, and maybe this data is in CSV format, and you want to convert it into JSON or Avro, for example, and then you want to store that into S3. This is a pretty common type of use case, and notice in this case, the convert record is the only record-oriented processor in this entire flow. That is to say, it's the only processor that has a record reader and a record writer configured. And whenever that's the case, it makes a lot of sense to use convert record to go from one format to another. So this is a really good use case for it. But the bad version is whenever we have some sort of processor such as consume Kafka record or any of the record-oriented processors as a source, or if we're sourcing the data from somewhere else that's not using a record-oriented processor, but we're already doing some other type of manipulation, like an update record or something like that, that's going to use record readers and writers, we don't need this convert record processor here at all. So in this case, if we look at the consume Kafka record processor, and we look at the properties here, we'll see that we're consuming using an Avro reader, and then we're using the Avro record set writer for the record writer, meaning we're pulling data from Kafka that's in Avro format, and then we're writing it out in Avro format. And the next step in the flow then is to use convert record that reads the data in that Avro format and writes it out in JSON. So here we're just trying to convert from Avro to JSON. So why is this a bad idea? Well, if we come up here and configure consume Kafka record, and instead just say we want to read the data in as Avro, but we want to write it out as JSON, that means there's no need for this convert record processor at all. We can just get rid of it completely and go straight from Kafka to S3. That's going to save us the expense of writing the data out in Avro. It's going to save us the expense of reading that data back in, parsing that Avro data. It's going to go just straight from Avro to JSON and then into S3. So it saves us quite a bit of processing just by eliminating that processor altogether. So we really want to make sure that anytime that we have another record reader and record writer in the flow, that we're not using that convert record in between. So that's the bad use case. And then of course we have the ugly. And what we see here, we have a processor that's consuming data in Avro, or writing out in Avro. We then use convert record to convert that Avro to JSON just like we did before. But what makes this even worse than the previous example is that the next processor in the flow is actually record oriented itself, meaning it doesn't actually matter what the format of the data is coming in. It can be anything. It can be JSON, it can be Avro, whatever, because it's going to use a record reader already. So in this case, we can go ahead and delete that convert record also. We can write it out in Avro, and then we can go ahead and read it in Avro. Or we could write it out in JSON and read it in JSON if we wanted to. But the reality is that even if we were consuming this data from a FTP server or something like that, where there were no record-oriented processors before this final destination processor, there was no need at all to convert that data using convert record, because that intermediate conversion doesn't buy us anything. We were basically just wasting a lot of resources by doing the conversion at all. So Primary node only for the first processor in your flow. Convert record, only if it's the only processor in your flow that has a record reader and a record writer. All right, so the third topic we're going to look at today is writing overly complicated expression language. So if we take a look at this update attribute processor, it's got a couple of properties added here. The first one has a value or a name key and a value of key is null, if else null key. So it's kind of hard to read here. It's basically telling us to look at the key attribute, check whether or not it's null. If it is, then return the string null. Otherwise, return the actual value key. I've seen this particular type of expression written over and over and over, where we've got an is null if else. And it turns out you can actually make this a lot simpler by just simply using key replace null with a string null. That becomes a lot easier to read. And then we see things get a little bit more complicated. So we want to say, okay, well, if the value is null or the value is empty, then we want to use an if else. And if it is null or empty, then we want to replace it with 2 dashes. Otherwise, we want to replace it with the value attribute. So there's a couple of things that we can do here. First, it's important to note that we can actually use Shift and Enter in order to insert new lines. And this can make these types of expressions a little easier to read. But more importantly, we can get rid of all of this and simply use something like value replace empty with a dash dash. And that's going to do the same thing as that whole big long expression. But of course, I don't expect every user to actually understand all of the different functions that exist in the NiFi expression language. And so one thing that is extremely helpful that I think a lot of users, especially new users, don't realize exists. If we're using the expression language, we can actually at any time press Control and space. And just like an IDE would give you autocomplete and documentation, NiFi will do that as well with the expression language. So here I can start typing a function and I can see what's available to me. So I can come down here to replace empty, and it's going to give me a description of what that function does. It's going to give me a list of all of the arguments and an explanation of each one of those, and the type of return value and the subject. The subject is basically the thing before the colon, so the thing that this is being evaluated against. So here we can, again, press Control space, come down here to replace empty. And that can make your life a lot easier. But it's also important to note that we don't just have the documentation inline right there. Press OK. And if we come over here to the global menu here, we can come down to Help. And we can come over here to the expression language guide right here. And this is going to show us an overview of the expression language and how it's used. And it's also going to show us every function that exists in our expression language. So if we come down here to replace empty, you'll notice in the documentation here, we're also going to have examples for pretty much every function that you look at. Some of them have just 1 or 2 simple examples. Some of them have a table that shows several different examples. So it gives you a lot more understanding of how these functions work. It'll help you to understand the syntax that is expected and that sort of thing. But of course, it's the help menu here is not just limited to the expression language guide. We have the entire user guide right here, which is really nice because the documentation is going to change for every version. As new features are added and that sort of thing, those features get added in. And of course, this documentation pertains to the actual version that you're running. So we've got the overview, we've got the admin guide, and we've actually got the documentation for every single processor that we have in our flow. We have, of course, the documentation for every controller service and reporting task as well. And it's also worth noting that some of these processors are fairly complex to use. Merge content is extremely powerful and it gives you a lot of different options, but that can make it a little bit cumbersome to use if you haven't really learned all of the different properties that it has and that sort of thing, and learned all of the different use cases. So if we come to the documentation here, a lot of the processors will have this additional details link. And if we click that, we're going to get a whole lot more documentation about that particular processor. And if we close this out, it's also worth noting that from any of the processors that we have on our canvas here, we can actually right click and we can say view usage, and it'll open up this help tab and it'll take us right to the documentation for that particular processor. So it turns out NiFi is actually pretty heavily documented. There's a lot of different documentation throughout this project, but I want to make sure that all of you guys are aware of exactly how to get to that documentation, and even that the documentation is available to you. All right, now the final pattern that I want to take a look at today is this idea of logging attributes all throughout the flow. So a lot of times we see users building their data flow and they'll have these little side flows all over the place where they send data to a log attribute or a log message processor just so that they can go back and look at logs and understand everything that's going on throughout their flow. And I realize that there are some organizations that have certain regulations around things that have to be logged and that sort of thing. But for the vast majority of the use cases, users are just adding these in for debugging purposes as they're building their flows and so that they can understand exactly what's happening. And so one of the things that's important to note that people often don't think about is the fact that while logging is generally pretty cheap, it's not free. It does come at a cost. So to illustrate this, I've got two data flows set up right here that are just going to generate a whole bunch of flow files with no information and just destroy them. But in this case, I'm going to go ahead and log the attributes. And so we're going to start this just to kind of show a comparison of the performance that we can get out of these two approaches just by adding in that log attribute processor. So just click start. If we refresh a couple of times, starting to see that the flow on the left here is processed a little bit more. And so let's go ahead and refresh a couple of more times. At this point, the flow on the left's done 50% more. I'm getting pretty close to this flow over here, doubling the data rate of the flow on the right. But it's also important to note that as the data is flowing through here and we start logging all of these attributes, that's a lot of information that gets written into our log file. So if we do have any problems arise, any warnings and errors, they become really difficult to find. It's a lot of data to sift through, even using tools like grep and that sort of thing. And if you have to share your log files with anybody, it becomes a lot more trouble if you have to tar and gzip many gigs worth of data just to send to somebody so that they can take a look at these logs. And so the alternative that we provide in NiFi is what we refer to as data provenance. So to illustrate what this is and how it works, let me start this flow here. And to make things simple, I'm just going to trigger the generate flow file processor to run one time. So just generate one flow file. And we can see the flow here is just going to split that up, replace text, so it's going to modify the data in some way. If we look here, we're going to change the word dog into the value cat. And then we're using merge content to merge all of the data back together. And then we have an update attribute here that's going to basically just get rid of the flow file for us. And so if we view the data provenance on this particular processor, what we see is that one event has occurred. That was a create event. So if we come over here and click on this icon, we can see all sorts of information about this event. The fact that the file was 65 bytes when this occurred. We can see the different attributes that existed on it at the time. We can view the content. And from there, we can actually click this icon over here that shows the lineage of the flow file. So we can see that the flow file was created, it was then forked, and then it was dropped, and it was subsequently downloaded. That download was whenever I just clicked the icon to view the content. But this fork event is interesting. If we expand that, we can actually see that this one flow file was forked into 3 children. Each of those children was then modified. So if we look at the content modified event, we can see that that happened by the replace text processor. If we look at the attributes, we can see that at that point in time, after that event occurred, the fragment size was 20, the text line count was 1. We can look at the content, and we can actually see the content before and fell in the hole. We can see the content after is also and fell in the hole. If we look at the content modified for one of the other events, Fox jumped over the lazy dog, and after, we can see Fox jumped over the lazy cat. So we can see that that content did in fact change there. If we've configured our data flow incorrectly, we can go in and make updates to our data flow, and then we can click replay, and would replay just that particular piece of data. It would put it back in the queue, and it would play from that point on throughout the rest of the data flow. And then we can come over here to our join event, and we can find its parents, and we can expand. So we can see after we took these 3 flow files, we joined them into this one new flow file. Each of those 3 flow files then had their attributes modified, and then they were dropped. 2 of them were downloaded, twice in fact. Once because I just viewed the before, and once because I viewed the after. And the output of that join was this new flow file, which then had its attributes modified. And subsequently, it was dropped. So we see a lot more information than those logs are ever going to give us. We can also search this provenance repository for things like file name, or you can have it index specific attributes that you care about so that you can go back and search for those later. But this gives us a lot more information than those logs. And if you're running in a clustered environment, we're able to view what happened to data throughout the entire cluster, all from this one UI, rather than having to aggregate logs across many servers or log into many different servers to grep against the logs and that sort of thing. So it gives us a lot more information in a much easier to understand, much more presentable way. Okay, and that's all I'll have for you today. 4 pretty quick and easy lessons that hopefully help you to make better use of your NiFi instances. So thanks for taking the time to check out the video, guys, and please feel free to share it with anybody else who you think would benefit. Thanks.